Hi, I'm Amelia Curran. I'm from Indialantic, Florida, and my project was comparing the efficiency, free fatty acid percentage, and carbon dioxide content of waste vegetable oil and Brassica carinata biodiesels. I did this project because climate change is one of the biggest problems that my generation and future generations will have to face. Our planet is warming at an alarming rate, and one of the biggest contributors of this is carbon dioxide, a greenhouse gas that is produced when we burn fossil fuels for our transportation. By transitioning from fossil fuels to biofuels, we can reduce our carbon footprint and be kinder to our planet. For my project, I produced 2 biodiesels, one from waste vegetable oil and one from Ethiopian mustard, also referred to as Brassica carinata. Biodiesels are produced through the transesterification process, which is a chemical process that uses triglycerides, a catalyst, in my case sodium hydroxide, and methyl alcohol to produce fatty acid methyl esters, which are biodiesel. Before I could do this, I had to extract and purify my oils. When I got my Brassica carinata seeds, I put them through a soxhol extraction, which is an extraction procedure that uses percolation to extract the solute. While that was going on, I did an acid-base titration on my waste vegetable oil to determine the amount of free fatty acids were in it. Free fatty acids are detrimental to the transesterification process because they react with the catalyst. There isn't enough catalyst to fully convert the triglycerides and methyl alcohol into fatty acid methyl esters, which leads to incomplete processing. Incomplete processing is detrimental to the engine and when the fuel is burnt. Once I produced my biofuels, I put them through 2 tests, a carbon dioxide content test and an energy content test. For my energy content test, I took 2 milliliters of fuel and poured them into a metal tea light canister. I set that on fire and placed it underneath a soda can filled with water. I measured the temperature change of that water and multiplied it by the heat capacity of water to find the amount of energy that was produced. Once I did that, I did my carbon dioxide content test, which I yet again put 2 milliliters of fuel into a metal tea light canister and set aflame. I placed an upside down funnel on top of this and took an oral syringe and sucked up the smoke produced from the fire. I injected that smoke into 20 milliliters of water and did an acid-base titration to find out the amount of carbon dioxide produced from the fire. When I did my project, I hypothesized that waste vegetable oil would have a higher energy content and lower carbon dioxide emission than Brassica carinata. This turned out not to be true. When I did my testing, I found that the waste vegetable oil biodiesel would not set aflame for unknown reasons. I ended up testing the Brassica carinata biodiesel against my control group, which was E10. When I did this, I found that the Brassica carinata biodiesel had a higher energy content and lower carbon dioxide emission than the gasoline, E10. I did statistical analysis on my data, specifically an unpaired t-test, to find the statistical significance, and it found to be extremely statistically significant with a p-value of 0.0020. These results show that that there can be a biofuel that is produced that is more efficient and more environmentally friendly than conventionally used fuels.